Should I try doing it?
Yeah, it's working now.
Cool. So I clicked recording to the cloud. Is that right?
Yep, that's right.
Cool. So we're recording. Welcome everybody to the first Code With Us session. Just saying that this is a new program, so it's experimental, and we're going to be kind of playing it by ear, see what works and see what doesn't. Workshops are difficult in general to get everybody sort of on the same page. Doing it remotely is probably not going to make it any easier, but we'll do our best. I've put a link in the chat to the Discord channel. So that's a place that's a little bit more permanent for us to talk to each other if we want to. I'm going to try to keep the Discord open on my phone next to the computer. You can also send me messages directly with Zoom. I might at some point just mute everybody in case there's sort of noise coming through and we can't figure out where it's coming from, so be aware of that. Otherwise, screen sharing is turned off. Hopefully we don't have any Zoom bombing. Oops, I sent it to just one person. Let me send it to the whole group again in case it's not there. Inside of the Discord, you can also see I added a link to Cutly/Scavenge. So that's a HackMD page where I'll be posting some links as well. The first one is just a link to that same HackMD. Second one is the link to that Discord channel. Third one is tutorial. We're going to get to that in a minute. And the fourth one is to be announced, but a live server. And the idea behind the live server is, so what we're going to do is I'm going to briefly talk to you about the Cosmos-SDK, sort of the architectural decisions and like how we built it and why it sort of makes sense for building apps. Then we're going to jump into the tutorial and actually build this sort of game app that I made a tutorial for, I guess, a few months ago. Everyone's going to sort of build a local version of this application, and they're going to run it locally. And then at the end, you're going to use the code that you built to connect to a blockchain that I'm running in the cloud right now on a DigitalOcean server. So that blockchain that I am running, I set up beforehand with some challenges. So once you've built the sort of tools to interact with the blockchain, this specific app, you're going to be able to interact with the one that I have running. So we're all going to be talking to the same blockchain. And we're basically going to run through some challenges. And anybody who can solve the most of those challenges will receive points when they do that. And at the end of all of this, whoever has the most points will receive some swag in the mail. So we'll just make sure to stay in touch to make sure that whoever's the winner there is going to be able to receive probably a t-shirt and maybe a little bit extra stickers or something like that. So we've got the links there. You know how to talk to me. If there's nothing else, anybody have initial questions? Otherwise, I'll jump into the first sort of quick presentation about the SDK. Going once, message me, going twice. Cool. Then I'm going to share my screen and we're going to begin. Okay. Does that show up for everybody?
Yep.
Cool. So this is a version of a talk that I gave before at a Golang conference called Digital Scarcity in Gaming and Golang. A little bit about me first. My name is Billy Rennekamp. I'm from, oh, I got a message. Let's see. Oh, this is just from Adriana. Let me repost her message for everybody. You can see that in the chat. So I was just saying, I'm Billy. I'm from Louisville, Kentucky. I'm the grants manager on the board of management at the Interchain Foundation, as well as developer relations head at Interchain GmbH. Previously, I worked a lot as a freelancer. You can call me mercenary if you want to make me sound badass. With a group called Ben Studio, doing dev and design work. We built Clover's Network, which is a Ethereum game. It's an NFT scavenger hunt sort of game. And I also did some work with Gnosis and Aragon Black, mostly around bonding curves, automated market makers, all the sort of fun topics that are mostly living inside the Ethereum ecosystem that are sort of ready to be implemented in sort of modern architecture like the SDK, which I'm sort of looking forward to in many aspects. Favorite topics of mine, traditionally I was doing a lot of JavaScript development. My favorite framework is Vue.js. The last year or so I've been working a lot more in Golang, learning mostly, working with the Cosmos-SDK. I mentioned I built this Ethereum app. That was a lot in Solidity, so I have a pretty extensive history in Solidity and Ethereum working. curation markets, this sort of stuff around automated market makers, and hackathons. I'm a big fan of hackathons in general. If you want to chat about hackathons sometimes, let me know. Got another message. Silly Tuna lost all audio. Can I get a message from anybody else that can either confirm they hear my audio or can confirm they cannot hear it? Can hear, can hear, can hear. So everybody can hear right now. Tuna, are you still not able to? Still not, has left the meeting. Okay, maybe he can join back again and it'll be fixed. So I skipped a bunch of these slides that I usually talk about to just jump straight into sort of talking about the Cosmos SDK. Typically, I would sort of give a background of how we got here, which is, you know, Bitcoin, which is in some ways an application-specific blockchain, and then Ethereum, which is mini applications all on the same blockchain. Some of the problems with each of those when it comes to sort of scaling, and sort of the way that we think about the solution, which is this idea of an internet of blockchains, in which you have a bunch of application-specific blockchains. So I'm going to try to avoid even calling them blockchains. I like to think of them as just apps. So if you ever built like model view controller applications with Ruby on Rails or something like that, you know, you're building an app. The difference here is that SDK apps are state machines, and they have data integrity, and they have a networking layer for those state updates. And as a benefit of that, you basically get money as a primitive in your programming language. So I'd really like try to avoid thinking about these as blockchains and really start thinking about them as applications, and really, you know, allow yourself to think about the flexibility of what an application is, and just think of these apps as ones that are sort of supercharged with the ability of having money sort of directly integrated. So you're no longer working with a Stripe API or a PayPal API when you have money in your software app. The money is just literally part of the app, which is, I think, a really sort of cool and incremental improvement on the software world itself. You know, I think that blockchain often gets bogged down with the sort of massive endeavor of the ideological and sort of like political gains that are possible with these systems. I think that that's a very viable sort of outcome, but I think that to get there, it's important to sort of focus on what is the very like small real improvements we can make on the traditional software stack. So that's what I'm going to be sort of focusing on. And the way we think that's really the best way to sort of achieve that is to make a really easy to use software development kit. And so that's what we're calling Cosmos SDK. I mentioned Ruby on Rails. You know, we kind of refer to it as Ruby on Rails for blockchains. It has some cool features. It's modular, meaning that you have sort of like libraries that you can import and just use out of the box. So if you're familiar with JavaScript, you know, using NPM or something like that, if somebody's done some work on a cool feature that you want to use in your app, you should be able to just import it and use it with like minimal modification to sort of fit your use case. And that way it's also extendable. It uses Golang, like I said, one of the most popular and robust languages. Proof of stake, I'll get into that in a second. Uses a concept of least authority. So this is a security measure that sort of allows these different libraries to not have too much access or control over their neighboring libraries, these neighboring modules. So that's just a security feature that we'll also touch on a bit. I mentioned proof of stake. So the way that sort of we've made it easy to build applications is by taking care of the hard stuff for you. Traditionally, the hard stuff is about consensus and networking. So this is sort of why it was so hard to build anything different than Bitcoin in sort of early days, and why Ethereum was largely so successful, because they take care of the networking and the consensus, and they just let you focus on the application. So we also sort of take care of those things, but in a different way. And the real sort of secret sauce behind that is Tendermint. Tendermint's mature state-of-the-art BFT. BFT is Byzantine fault tolerant, and this is part of academic computer science work that's, you know, 30, 40 years old. And it's basically how do you get a bunch of computers to come to an agreement about some data? It's pretty easy to do that when you're running all those computers yourself. It gets much more difficult when you allow strangers to run those computers, strangers who are potentially malicious. Byzantine is the word. And so traditional BFT work was really geared towards pretty small sets of computers coming to agreement. And Tendermint sort of took that work and extended it to allow very large groups of computers. So, you know, we typically recommend in the hundreds, but it's possible to do it in thousands without sort of the performance kicks that you would be afraid of. Getting into that territory, you start having options with ways to make optimizations. Our sort of idea generally, though, is that you shouldn't be scaling, I believe the term is vertically. So vertical scaling would be like, yeah, we can fit everybody into this single sort of validator set. We're going to have thousands and thousands of validators, compared to horizontal scaling, which is the idea that why don't we just have, 10 different networks that each have 100 validators, and then you have 1,000 validators. And none of them have any of the performance hiccups that you would expect from a really large set. And then the real sort of way that that system is able to work is by gluing them together with something called IBC. So if they were all in their own silos, they would never be able to communicate across them. But when you have something like IBC, which is essentially like TCP/IP for the internet, permissionless transport protocol that allows you to move information between computer networks or between blockchains in this instance, then this sort of like 10 discrete blockchains really become sort of one blockchain network, and so IBC is really the glue that holds together this whole vision of the application-specific blockchains, so that you actually can have these different discrete applications, but still have them interact with each other, the same way that applications on Ethereum can interact with each other inside the EVM. They can reach into each other's state. They can trigger functions on each other. They have basically open APIs. IBC allows that. That sort of opens up the possibility for an internet of blockchains. We hope for the Cosmos Hub, which is a blockchain that's been running for the last year, to be basically the plumbing of this internet. One of the options, I've got IrisNet on here as well. Somebody was mentioning it earlier. They're another sort of hub. And the idea is that similar to the way the internet works, there's many hubs. There should never be just one hub because that has too much sort of security risk going in through there. So there should always be options that you can route your traffic through different hubs depending on what your use case is. So early on, Cosmos and Iris were sort of made a partnership to make sure that both would be successful, because the vision doesn't work unless both are successful, or unless there's more than one option in general. So build applications, not blockchains, as I was saying earlier. Before we begin, are there any questions anybody wants to bring up? Any of that confusing? I imagine you guys already know a lot of that. I'm kind of expecting most of you are familiar with Cosmos in a general sense, but I wanted to touch on that sort of a bit before we get into actually building an application. So I don't see any questions coming through, so I'll assume no. Then let's talk about our application. So I've been calling it a scavenger hunt. You might also call it, oh, we got a question. Slide available. Like the links to the slides? That's to Solomon. If the question is about, can we have links to the slides? Absolutely. I will make those available as soon as the talk is done. I don't know, we're going to be moving out of them in just a second. So there's nothing here you should worry too much about. And a lot of the information is going to be in the tutorial that we switch to in just a second. So basically, scavenger hunt, anyone can post a question with an encrypted answer. They're going to encrypt that answer basically by hashing it, SHA-256 hash. Each question that they ask comes with a digitally scarce bounty. So you're going to be able to attach some reward in the denomination of coins. Anyone can answer that question. And if they're the first person to answer the question correctly, they're going to receive the bounty. So I have a picture of like Rumpelstiltskin here. If you're familiar with the story of Rumpelstiltskin, you know, he's going to, I don't know what it was. He was going to like not steal your baby if you could think of his name or something like that. So this is a little bit like that, except for instead of receiving a baby, you're going to receive some coins. Something you should be aware of with blockchain apps in general is the idea of front running. So the general sort of user flow of creating interactions with these applications is that you sign a transaction with your intention to interact. So you say, it's a bit like writing a check at the bank. You know, you write a check to somebody to pay your rent. You say, I'm going to pay you $1,000, whatever your rent is, and I'm going to sign it at the bottom. So you actually haven't, you know, made that transaction yet, but you've signaled your intention to do so. And then once that transaction is submitted to the bank, the state update function takes place. Hey there, Sid. I'm just walking through a little bit of intro information about why you might want to build an application like this. There is a link to the Discord, I think, in the chat. Somebody else have that? Maybe you want to, actually, I can do it right here. So that's a place for all of us to talk. And inside of there's also a link to a HackMD that's going to have some links. And afterwards, I'm going to put these slides up. But just a second, we're going to move over to a website tutorial so everybody will be able to follow along there. If there's anything specific that you feel like you're missing out on, feel free to chat here or put in the Discord and maybe somebody else can help. So in this sort of application system where you've got this like check, this check hasn't cleared the bank yet, it's circulating in the real world, you have sort of the problem of front running. So imagine you wrote this check to somebody and then you wrote another check to somebody else and you spent all the money in your bank account. When that second check comes in there, there's going to be no money in there. So that's a bit what's happening with blockchains. You submit these transactions, they're circulating around the world, they're getting gossiped by all these validators, they get included in a block, and they might be deemed valid to be included in the block, but when they actually get processed, they might become invalid. And so this sort of moment where there's sort of a unknown about is that transaction valid or not, you have everyone who's basically able to look at them. And this can cause a problem in a situation that we're working with called front running. So in the situation that you've basically said, hey, I know the answer to this really important question, I'm going to get paid when I find the answer. You submit the answer to this, public validator set. It's like your check is now public and visible to everybody. Anybody else can see the answer as well. And it just so happens that, they have 5 seconds basically to also submit the answer after they saw yours. 5 seconds is a pretty long time in computer science. So they might submit their own sort of transaction that says, hey, I know the answer, I figured it out. And they might even sweeten that transaction with some like really high fees so that validators decide to include it before the original person. And that way they're basically able to cut you in line and steal your reward, steal your bounty. So what's usually implemented to prevent this scenario is something called a commit reveal scheme. Commit reveal scheme means that you first commit your answer and then you reveal it afterwards. So you make 2 separate transactions. When you commit your answer, you don't actually show the answer itself. You show a scrambled hash of your answer. So you can see here, there's this like function that says hash, parentheses, answer plus name. That will result in a sort of scrambled text that nobody can really determine what it means. But you submit that with your name. That gets stored in the app to begin with. Then you submit the actual plain text with your name because you're the person who submitted it. The application itself will take the answer, add your name to it, scramble it, and then it'll look for that hash inside of its storage. It previously stored that when you made the commit transaction. If it finds it, then it'll hash the answer. If the answer is correct, you get the money. But what's really great about that is that if you just submit the answer in your name and they can't find the original commit, they're not going to give you the money. So if you tried to say, see somebody's reveal and you tried to like front run the reveal, you submitted the answer plus your own name, that's going to result in a completely different hash, a completely different commit than the one they did. And so it's never going to get accepted. It's going to get thrown out. So this is a way to sort of prevent people from front running you. And we're going to implement this in our app as well. What's kind of cool about this app is that it's very sort of simple. It's a dumb thing in a way. It's just a simple commit reveal with a reward, but it could really open up the possibility for a pretty robust or interesting user experience. I like to think of the sort of traditional gaming experience. Say you're playing something like Zelda. You have all of the software for Zelda on your whatever, N64, whatever the current platform that you're using. At the end of the sort of game, when you beat a boss or you beat a super boss or whatever like that, the game itself could give you the answer to a question, which was previously, hashed and stored on a blockchain that came with a reward. So if you're the first person to sort of uncover that answer, be the first person to beat that level, or maybe there's an answer for every single person is deployed, but you're able to sort of have all of your game mechanics happen on a software platform that's built specifically for that, and then transfer that one sort of like nugget of information, which is the secret password to recover the reward, submit that to a blockchain, and then get paid in a sort of a coin system or a point system, which could be recognized by that game platform itself. And so you have sort of a half traditional game stack, half blockchain system in which blockchain is just doing things that blockchains are good at, but still allowing sort of like a fully trustless access to a point system or to an economy, which is integrated into a game itself. So without further ado, maybe we should hop right into the tutorial. You can access this at tutorials.cosmos.network. There's also a direct link inside the HackMD that'll take you to the specific tutorial we're talking about, which is the Scavenge tutorial. So I'm going to stop sharing for a second and then start sharing again with that screen. While we have this moment, is there any questions in this transition period? So, okay, gonna share again. on this. Okay, so here's the tutorials.cosmos.network page. You can see I jumped ahead. I gave a little bit of this background that I skipped before about state machines and what that means, as well as describing the game itself here about front running and how, again, the example of Zelda, you could use it in a real video game. And we're gonna step right into scaffold. So if I actually change my share to share my real screen, what does that look like? Maybe I'll just switch it to iTerm. What's the best way to do this? Okay, you're just gonna have to assume that I have a terminal open and that I'm using it. So the first sort of instructions say to use scaffold. If you've ever used Ruby on Rails or Laravel or Cake PHP, you'll be familiar with the concept of these sort of command line tools that help you quickly spin up a boilerplate app, and then you can jump in and sort of tweak the things that need tweaking. We're using a similar system here. We call it the scaffold tool, and it helps you sort of take care of all of the sort of crud that you would just sort of copy and paste generally when building a new app. There's a lot of sort of plumbing there, and a lot of it's necessary because you want to be able to go in and tweak it if you have a situation that requires it. But if you're just sort of using an out-of-the-box app, you know, we're able to basically skip tons of the sort of plugging and playing that takes place otherwise. So I like to begin by asking you to clone a repo. It's under Cosmos/scaffold. I'm going to clone that right now, so hopefully my timing is similar to yours. Git clone, git clone, GitHub, Cosmos, scaffold, cloning in a scaffold. So I'm using just kind of a home directory here. If you have a special place you'd like to store your code, I suggest moving there. Once you've cloned it, you can change directory, scaffold, and run make tools. So this is going to make sure that you have Go bin data basically is the tool that's probably going to get installed. And that'll allow you to run make install. And this is actually going to build this command line on your computer, and it's going to put it inside of one of your binary folders so that you can access it by default. So to kind of make sure that it's there, you might run scaffold help. And I'm going to share to, well, you can do a new share. Can you do multiple shares at the same time? I'm not sure if I'm doing multiple shares or you're just seeing my terminal now, but hopefully you can see that in my terminal, I just ran those commands. I ran make tools, make install, and I ran scaffold help. You should see this sort of help command that tells you what scaffold's good at. So once you're sort of sure that scaffold works, you can use it. It has a few commands into it. The first one is app, and that builds the basic boilerplate for a general app. I'm going to call this app Scavenge, and I'm going to use my GitHub username, which is OKWithMe, OKWMe. Got a chat. Oh, I guess I'm not sharing the terminal. So stop share, reshare, terminal. So here you go. I did git clone, then I changed directory, make tools. This is where Go bin data was entered. Make install. You probably had actually a lot more output from make install. I think that I have it currently installed on my machine. But then you run scaffold help and it'll show you the basic command. So you can also see down here that you have the help, which we just used. You have app, which generates an empty application boilerplate, and module, which generates an empty module. So we're going to be using both of these, but first we want to start out with an application. So my app is going to be called Scavenge, and I'm going to reference my GitHub username because the way Go works with naming projects and their module system, they want to know like what's the home or something like that. So you could imagine my home might eventually be GitHub. So I run scaffold app. I'm going to use level 1, which is the most sort of simple, low level, not a lot of features application. There's a higher level one that we're not going to get into now, but you might check out at another time. So that command goes scaffold app level 1, okay with me, scavenge. I run that and I got a chat. Let's see what that says. Having trouble. Wait, here we go. some people are getting an error. Mention the Discord chat. Cool. Let me jump to the Discord chat and see what I can see. Shoot. Somebody have it when, there we go. Oh no, silly tuna, I'm sorry. This tutorial requires a specific version of Go. Getting this error. Make tools. Go bin data latest. Go get bin data and matching version of latest. Okay, this looks like it might be a Go root. What is it? A Go bin error. So if you installed Go, there are often instructions for setting Go bin and Go home or Go path. Let me see if I can find a quick tutorial that might help you guys out. This is generally the sort of weeds that often end up taking up the whole workshop. So let's see. We've got some Go experts. This would be a great time to jump in there. I'm sure you're also familiar with this problem of not having correct Go bin or Go home. Go home shouldn't be necessary anymore with the newest version of Go, I think 14 or something like that. But Go bin data might require it. And so it might be that you need to change your like bash RC or your profile inside your home directory that includes the Go home to your path or just sets Go home, Go bin, or Go root. I'm going to try not to spend too much time on this again, because like I said, it can be a real time killer. And the hope was that we'd have Go set up beforehand to avoid it. So I'm going to switch back. Let's see. How many, maybe can I get a show of hands who aren't able to install the scaffold tool right now? So if it's, I mean, if it's a very large group, then let's try to squash it. If it's a couple, then we might just need to do some individual helps. So Tom Heller raised a hand. Maybe it's easier to raise your hand in the Discord.
Akihugale found a ran a quick fix and he posted it in Discord.
Awesome. Got Go working at least. So that's something. You want to try those advice out, Silly Tuna? That might help. I don't know if turning it off or on. You might need to run something like source after you make changes to your bash RC or your profile in order to make them show up. You can do that. You can do stuff like that inside your terminal to see if it's actually set now. I'm not sure exactly what needs to be set in this situation, but I know this is annoying sometimes. Okay. So if you were to just run scaffold app level 1. Oh, you know what? Also, if you're not able to get scaffold to run, you could, and everyone should think about this as well, you can clone the tutorials repository. So that repo is at GitHub, Cosmos/SDK tutorials. If you clone that, and then you cd scavenge, you're going to have a completed application. You can also, of course, look through that GitHub yourself to sort of, if you're not able to build the code in real time, you can always feel free to jump into the file that we're working on and see a completed version of it. So that's useful. Even if you're able to use make, install, and all that, you might still want to use that as a reference. I'm going to put that into the HackMD as well. Oh, no, it's already in there. Well, the readable tutorials, but I'll put it as a GitHub. Cool. Yeah, so the Go bin data not found. I think that's a Go home problem, which is being referenced in the Discord, Lingamurthy. This can be frustrating, I know, but I promise once, this is sort of like early days of NPM. If you guys ever remembered when that first came out, how awful it was to have conflicts and just sort of have to nuke your entire repository and do it again. Go introduced Go modules in the last like 6 to 9 months. So it's still in sort of like a little bit annoying configuration baby phase, but after that, I can promise there's a lot of amazing improvements on at least the JavaScript developer's experience. So, so after you build that app, am I sharing my terminal right now? Yeah.
Yep, your terminal's there.
Yes.
You can see if I list my files, this is what it generated for me. I'm going to move into, oh, sorry, it moved into Scavenge. This is what it generated for me. And I'm going to move into X. This is where sort of like executable modules are. And we're going to run a new command that's in the tutorial that's instead of scaffold app, we're going to do scaffold module. So if I just copy that, paste in scaffold module, I'm going to use my GitHub username again, okay with me. Scavenge is the name of the project, and I'm going to call the module Scavenge as well. So that creates all these files inside of a new folder called Scavenge. I can jump up a bit again and see the normal application, and I know now that inside of X is my new module. So that is part 1, the scaffold. I'm going to click next into the messages page. Now I am going to, I guess it makes sense. Let me try sharing my actual screen because I'm going to be switching between apps, and that might just make these things. You might see some private messages. So far, everybody's sharing very tame private messages. So I hope that's okay. Cool. Here's my terminal, and here's section 2. So generally, a way that's nice to think about building these apps is to first think about messages. Messages are actions that users can take. They're things that a user can tell to this app and say, do this for me. They get included in transactions and they update the state. So if you're familiar again with this like kind of model view controller system Ruby on Rails, you might think of I think it's the controller who does these, and often you'll generate like a CRUD interface that has create, read, update, and delete. So in this situation, it would just be create, update, and delete, because reading doesn't actually change state, just creating, updating, and deleting does. And so you can think about what are the things that we'd want to do in this app. First one is create a new scavenge, create one of these new challenges. Second one is create that commit. You know, if you think you have the answer and you want to do your commit reveal, first you need to commit it. And then the final thing you want to do is reveal your solution. So these are all the things that are specific to this module that we're building. But of course, you know, we're using the Cosmos-SDK and we're getting the benefit of all these other shared modules. So stuff like, you know, just having an account, checking the balance of account, having coins that come from a bank, you know, using Tendermint and having a validator set. These are sort of like default modules that we're going to use as well. Right now, we're just focusing on this new module that we're adding, but you're going to see reference to some of the other modules from time to time, like coins. You see on my screen right now. This is coming from you know, the bank module, and it's a feature that we get to use just sort of out of the box. So if you look inside of your generated files in that X, you're going to see scavenge, and you're going to see types. Inside of types, you're going to see this file called message. So that's just a general sort of generic version of message. Let's use that file to make our first message type. I'm going to open this inside of VS Code, and we can start going through it really kind of together. So what else I'm going to do is I'm going to use a terminal here so we can stay on the same screen. And I'm also going to get init and get add everything. So this way we're going to be able to see what are the changes that we're making from the actual scaffold command by using the sort of fancy git commands here. So these are all included in the base. Now let's go into that message file under types, message. And let's look at what I have here. I'm just going to copy this and throw the whole thing in there. And now we can look at the difference to see what changed from the initial scaffold to the 3 messages that we just added here. Looks like my VS Code is taking a second. I wonder if it's worth doing reload window. I've got video, VS Code, all these things running. So you guys are probably familiar with that. How overloaded it can get, but it looks like it's showing up now. Cool. So let's click in there. And what do we see? So on the left is what the scaffold built, and on the right is what I have now. Mostly you'll see that the scaffold is commented out. So it gives you sort of the basics of what a message would look like, but then it comments them out. So if you were to uncomment them, you might see that there's this message caret action. So something I usually like to do is just highlight the action and then hit Command D, and it'll select every one of those actions on the page. And then you want to give it sort of a descriptive of what this actual action is doing. In our instance, it's create scavenge. You know, this was the first message type we talked about. So that's a quick way to sort of jumpstart changing this. You can see here's a struct that represents sort of what's contained inside that message. And this is everything you'd expect. First, it's the creator, and it's using a type called an account address. So I mentioned that you sort of get some features of general blockchain apps out of the core SDK modules. One of those is just an account address, which represents, you know, a private key user, basically, public key user. The description of the scavenge. So this is basically a place where you could, you know, describe the tantalizing hint of how somebody might solve it. The solution hash. This is the, you know, SHA-256 hash of the solution. So you can't really tell what the solution is by looking at this, but this essentially tells you whether you're right or wrong if you think you know what it is. And the reward. This is all the money that you get if you actually do it correctly. So I mentioned before the SDK coins is a type that's coming from another module. That is basically a multi-denomination. You can think of that as an ERC20. It is a integer-based coin system. So on the Cosmos Hub, for example, you might have 1.0001 atoms or something like that. But what you actually have are a integer of what are called U atoms. So the real sort of denomination on the Cosmos Hub is U atom, and the convention is to use 10 decimals. So the convention on Ethereum is to use, I think, 14 decimals, and the convention on Cosmos is to use 10. But it's up to the sort of front end, the wallets or whatever, to sort of display those decimals correctly. So that's sort of up to you as well, how you want to handle it. We're going to just be basically thinking of one coin as one coin to keep things simple here, because we don't really have any fancy interfaces that would want to do different. And you'll see at the end when I'm actually generating these coins, you can make as many coin types as you want. There's different ways to, let's say, mint new coins in the Cosmos SDK or burn them. We're just going to start out with like a finite number that are all going to me, and I'll give them away, or in your situation, they'll all go to you. I think I call them foo, like foo bar, but you could always change that as well. So we have a little helper function to create the new message. This is just sort of passing in all of those things that are possible and returning the actual struct with them built in. To satisfy the message interface, you need your struct to have a few features. Those features are route, type, get signers, get sign bytes, and validate basic. If they have all 5 of those, then it's considered a message and it's able to be used as a general message. So any type of message, as long as it has those 5 things, can be processed by the application. The route is pretty simple. It's same as basically the scaffold said. You just return the router key. You know, that comes, I think, just auto-generated. We made this constant here, create scavenge constant, basically just a text ID for this message type. Get signers, this is where you would change it to message.creator, and that's where it says who inside this message struct is supposed to be the person who's actually signing the transaction. So that way you can't like submit a transaction for some other creator or something like that. You get the signed bytes. This is where you actually, you know, reorganize the message and check the signature that was taken from it. Validate basic. This is a way to confirm that the message isn't just invalid to begin with, without having to actually like jump into the application state and read anything from the database. So this is a way for sort of like very early flags to be raised, like, hey, you didn't do this right. The two things that we added here are basically, if you try to make a message without a creator, then we're going to give you an error, says creator can't be empty. If you create a message that doesn't have a solution hash, we're going to say, hey, you can't do that. Obviously, if you're going to like create a scavenger hunt, you need to have a solution. So those are our two sort of early sort of flag this message for not being valid. These are used by, I think, the validators to sort of process transactions or decide whether or not to even include them in a block. So this message might fail down the line. It might get included in a block because it has a creator and it has a solution hash, but there might be another part down the road where you realize, oh, this is an invalid message. But if it passes these things, it should be allowed to at least be included in that block. So that's the first one. If we scroll down, you'll see I just sort of repeated myself there. Second one, this message commit solution. Let's just go ahead and copy that and paste it into a new file. We'll call it message commit solution. Right here, let's see, new file, message create solution.go. Is that what it was? Message commit solution. How embarrassing. Rename message commit solution. Let's paste that in there. Let's also go back to this first message and let's rename it the one that we actually wanted to name it, which was message create scavenge.go. So I kept it as message before so you could see that git diff. Now it thinks it's like a completely new file, so the diff is not very descriptive, but usually you'd want to rename those. Let's see, is there anything interesting to recognize in the commit solution? You still have the scavenger. You've got the solution hash this time. This is somebody who's trying to show that they actually know the answer. First, they need to put that hash, it's basically the ID of the scavenge. And then they put that hash, which is the combination of their name and that solution, which basically puts them at the front of the line of who's allowed to claim this reward. Everything else is basically the same. You can also see invalidate. They make sure that there is a scavenger. They make sure that there is a solution hash, and they make sure that there is a combo solution hash and scavenge. The final one is message reveal solution. So let's copy that as well and make a new file. That was message, oops, wrong spot, right? We're in types. So message reveal solution.go. And now I can paste it in there. And let's just look through it really quickly. So this has the scavenger. This has the solution hash, which is again the sort of ID. And this time it has the actual solution in plain text. This is where you can actually read it. You can see this is a little bit interesting. When you create a new reveal solution, you only need to provide the actual solution because, you know, when you hash that solution, it should equal the solution hash. So you can see here, we're using SHA-256 library to actually hash it and then convert it into a string, a hexadecimal string. And then we use that inside of the message type. Later on, when we're validating, you can see we kind of do the reverse order. We take the solution hash, which was provided inside the message, and we take the solution hash string, and we make sure that if you were to you know, scramble that solution, that it would actually equal that solution hash. And if it doesn't, then that's an error because that means that you're providing some solution that is not the same as your solution hash. It's just a very small, immediate thing that we can flag as an error. So next you see this codec file. This is basically whenever you need to write data to the storage system that we have, you want to encode it into a really compact byte system. So we're currently using a codec called Amino. We're currently transitioning to one called Protobuf, which was developed by Google and is a bit more performant. But you need to sort of register inside your application that there are these new custom types, these new messages, so that when you're encoding or decoding, you know how to do it correctly. So we'll go into the scavenge types codec.go file, scavenge types codec, and we'll just overwrite that. And you'll see all you're really doing is just inside this register codec, you're registering a concrete message type for each of the three of those. So that's a necessary step. The other sort of necessary step here is alias. So with Go, it's very sort of like, context specific. So we're inside this types folder. And if you're inside this folder, all of these files are essentially the same file. Something that's in codec file is accessible by the arrows file, which is accessible by the events file. It's all basically the same thing. But if you go up one layer into here, you're not going to be able to access the things that are inside of types. So we want to be able to access those, and we do that with the alias file. So if you go in here and just overwrite it with what we had, we can look in the git diff. Looks like it's generating it right now. And we'll be able to see exactly what changed between those two. Oops. So we imported some stuff. Oh, it looks like we're importing Cosmos-SDK tutorials, although really ours is okay with me scavenge. So this is probably going to happen a few different times when we copy and paste directly from the tutorial, since the tutorial, is using the tutorial repo and we're using our own repo. I'm going to wait till the very end and do just a search and replace on those to make sure that they're correct. We remove the query params because we're not using the params module. Query or route, that's just a spacing error. That's not anything real. Here is where we add our new message types. So this is, you can see it's reaching into that types folder that we mentioned, and it's pulling it up and calling it this new variable name so that you can access it at this level of the app. And that's for the function for generating those messages, the new message create scavenge, as well as the message itself, message create scavenge. Phew. Okay, so that is our messages. After that, you want to handle storing those messages. That's in the keeper. So let's move over to the keeper. We're getting close to an hour right now. Should we take a quick break before we get into the keeper or before we get into the next step? How's everybody feeling? Can I get a, let's see, maybe I'll go to the, how are we doing in here? Looks like somebody got some success. Thank you so much for helping each other out. That's amazing. How's everyone feeling? 2-minute break or keep chugging along? I'm doing okay, but I know I'm going fast probably too. So maybe this is also a break for anybody to catch up. How do you guys feel? Who's still in sync? Maybe that's a, if you're in sync with me right now, let me know inside the Discord. If we've got a bunch of people who are lagging behind, let's see if we can maybe help them out, bring them up to speed. We got Marcel, we got Ian, that's great. Florian, awesome. Don't forget, if you stay in sync, you get the option of competing to win a prize. I've been dropping hints this whole time about questions that you're going to be asked later on. 1 minute break from Luigi. That's a quick one. We can compromise on that, right? So it's 1955. Going fast, Luigi. 1956 will be soon. But yeah, I've been dropping hints for the real scavenger hunt that's currently running somewhere in the cloud. I haven't told you the IP address, so you can't get a jump start on anybody else. At the end of the tutorial, you should have command line tools built that'll let you talk to it. And I'm going to ask each of you for your address that you generated in that process. And I'm going to give each of you a little bit of coins. You're going to be able to use those coins to make commits and reveals and try to win more coins. And at the end of all of this, whoever has the most coins is going to get some swag. If it's really, really close, we have 2 people who did a great job. Maybe 2 people get swag. I can't promise anything. I also have to check the swag storage. So it's probably t-shirts. We might just order something up fresh if it's very depleted. So you never know what you might get. Might be sick. Okay, it is 1956. Let's jump back in. Luigi, I hope that was a full minute. He's typing. Cool, he's in sync. So we're at the keeper. Great. So keepers are where you store your information. They are basically the database. They use something called a key value store. So key value store is a bit like a big, library or object, depending on which programming language you're most familiar with, which means that it has a key and a value. So in JavaScript, you've got an object that has a key and a value. This is just sort of like a bunch of nested key and value systems. And the keeper helps you sort of manage those. It helps you set up which modules have access to which keeper, which key value stores, which ones can share. In our situation, we're actually sharing a keeper across modules. I mentioned coins earlier. Coins are part of the bank module, which means that their keeper, you know, their basically their storage location is within the bank module. And so if you want to access the coins, you need to give permission to our new module. You need to give it bank module permissions so that it can, you know, do stuff like update the coin balance of some user who just won the big prize. So if we go into scavenge/keeper/keeper, that should be right over here. This is the thing that was just generated by the scaffolding. Let's paste in what I've got from the tutorial. We can go through and see what I changed. Wait for my slow VS Code update. Here we go. So the top, you know, the imports changed. Again, this is referencing the Cosmos-SDK tutorials instead of my OK with me, but we'll fix that later. So now you see this basic keeper struct. The generated one on the left has a store key, a CDC, and a param space. I won't go into params right now, but we don't really need them here, so I remove that. But we do want access to the bank keeper. So we're going to call it coin keeper, and we're going to reference it as bank.keeper. If you add that, it should automatically import this sort of github.com/cosmos, Cosmos-SDK, x bank. And you remember we're using this X folder to store our new module. That's exactly how the Cosmos-SDK is set up. It has this X folder, and inside of it, it has a bunch of different modules that do different stuff. So if you want to get familiar with other modules that are out there, how they're designed, how they're built, or advanced features, that's a great place to look, is to the docs on all the different modules inside the SDK, or jump into the code inside the X folder. So you generally want to have a new keeper function. This sort of generates it for you, similar to those new message functions. In this situation, we want to have the coin keeper as one of those parameters for that function, because, you know, to make a keeper for our module, we're going to need that bank keeper. So here you are just renaming it there, and it returns it. Pretty simple. Every keeper needs to have a logger. This helps you sort of keep track of what's happening. So keepers are generally set up with get and set functions. This is like any other app that you know, sort of where the what is the term, where the rubber hits the road or something like that. This is like what kind of interfaces do you really need when you're dealing with some storage system? You need to be able to get things from that storage system. You need to set things in that storage system. So some of the stuff that we're going to be working with are commits. You know, we talked earlier about what is a commit. It has, you know, this hash of what your actual solution is, plus a hash of what your name is inside there. Another sort of type that we're going to be dealing with are scavenges. And a scavenge is basically, what is the description? How much money does it have? Is there somebody who's already solved it already? What is the solution if somebody did already solve it? And so we're going to have functions here for getting those commits, setting those commits, getting those scavenges, and setting those scavenges. So before I go into all of those, you're going to realize that we're really talking about a brand new type here, a commit and a scavenge. And if you look back at the tutorial, we actually need to define these types somewhere. So I made a new file called types inside the types folder for these new sort of arbitrary types. So let's go ahead and put them in there. We're in the types folder, make a new file called types.go. We paste in, and so now we've got the scavenge struct. And now this is everything you'd ever want to know about your scavenge. It's got the creator, the description, solution hash, the reward. It's also got the actual solution. So this is just going to be nil. It's going to be an empty value until somebody solves it. And scavenger, this is the person who solved it. This is also going to be nil, empty basically, until somebody solves it. So you'll recognize this looks pretty similar to that create scavenge message. And that's where most of this information is going to come from during that, you know, initial message processing. We also added this string function to it. So this allows that struct to be printed as a string, which is really useful for us when we're running commands and we want to know, what the hell is inside of this struct. Here's our commit. It has a lot less information because this is the sort of like rather minimal info type. This all it has is the person who's sort of making this claim, the solution hash. So this is the sort of answer they're referencing. And this is the combination of the solution hash with their name, which basically allows them to be first in line correctly when they are first in line. It also has it's also what's called a stringer, has a string function, so it can be printed. So if we jump back into our keeper, let's look inside these functions a little bit. They're pretty basic. You create a store by doing something called context.kbstore with a store key. So that store key we defined earlier is just automatically coming from our module name. So when we ran that scaffold command, we gave our module a name. And so that was stored somewhere and set as a store key automatically for us. That can be modified if you want to. I don't know why you would. So now that we've got this store, we define this type commit. This is basically empty at this point. Then we create a new key. So inside of our store, we've got these keys and values, right? We want to reference the commit with a prefix so that if we want to say, pull out all of the commits from this key value store, and if we just start running through this object, reading every single key and every single value, it's gonna be really hard to tell which of these like things inside this storage are commits, which of them are scavenges. You know, there's sort of like, if they're both using a hash as the key, you know, inside this library, whatever it's called, a list, you're not gonna be able to tell if that hash is a reference to the commit or the actual solution. So we give it a prefix called the commit prefix. And that's gonna allow us to basically chop off the first 2 bytes of all of these keys and say, hey, what kind of thing are you? If I hop back over here, you'll see this is where I'm kind of explaining in the tutorial. We're gonna wanna store those inside of the keys file. This is just a little bit of utility to help us when we are doing something called iterating through our key value store. So I use the scavenger prefix is SK, the commit prefix is CK. As long as we know that these keys are gonna begin with that, we're gonna be able to identify what type of information is in the value part. So now when we're back over into this, whoops, where's the keeper comparison? Is that it? Yeah. Here we are. And now this is just adding that prefix to our solution hash. We're going to use that as the key. And now we unmarshal that, which basically means take this commit type and then put everything that you find inside the key value store under that key. So you see store.get byte key. Byte key is this combo we made. It's going to throw you back a bunch of serialized data. This is sort of why also we need that commit prefix, because if you just get back a stream of data and you're going to have no idea what that data is. If you know the type of that data, then you can serialize it into that type and you can actually read it coherently. But until you know what that type is, you're not going to be able to do that. And you're just going to think, this is a bunch of data. I have no idea what this is. So that's another reason why that commit prefix is really important, because when we know that it's a commit, then we're going to know what's that value. It's going to be of type commit. We're going to be able to serialize it, unmarshal it back into a coherent struct, which is that commit. And then we're going to be able to say, okay, was there an error in doing that? Like if you made a mistake and you're actually trying to serialize Scavenge instead of a commit, you get an error. If not, just return it. That means that you've sucked out the information from the database and now you're reading it. You're returning it back. That's a simple get. That's basically how the scavenge works as well, just using a different type. Set is the same thing, but just in reverse order. So now you're creating that key in a similar way, and they're using store.set with that key, but you're setting this stream of bytes. You know, this is where you marshal that data type into just a stream of bytes that are totally illegible to a human, but make it really efficient to store for a computer. So that's what we're seeing here. You can also see these helper functions called get scavengers iterator, get commits iterator. This is what I was referencing earlier, where you're able to take that store and run through every single value in it and check, does it have the scavenge prefix or does it have the commit prefix? And if it does, put it inside of an array and return it so that you get only values that have those certain types, that you know how to handle. That's something that we'll use inside of our query later. So that's talking about that. Let's go next to our handler. So our handler's in a similar location. Actually, it's a level above. It's xscavengehandler.go. Let's go in there and again, paste over whatever was given to us by our scaffold tool and sort of see what we did to improve it. Waiting for, oh, there it goes. Here it is. So after the scaffold came in, it gave you this sort of structure that says, yeah, you should probably put some message types here. And this is going to be a switch statement. So generally the sort of like flow of operations in a Cosmos SDK application is that you have messages. You know, we talked about what messages are. They get submitted to a validator. They get submitted to the network. They get gossiped. Hopefully the validators decide to include them into a block. Once they get included into a block, they get handed off to the actual application. When it hits the application, there is some routing that goes on. It says, okay, what type of message is this? What type of module is it associated with? Okay, it's associated with the scavenge module. Great. Let's give it to the handler of the scavenge module. The handler is basically the part of the app that says, okay, what do I want to do with this message that's coming in? It's basically like a router for what do you do with it. So you can see here we have the switch statement. Okay, I just got a message. What type of message is this? Is it a message create scavenge? Is it a message commit solution? Is it a message reveal solution? Or is it something that I don't know and I want to return an error because I have no idea what you're talking about? Hopefully it's one of those three. And we define a new function for each of them, handle, message, handle, message, handle, message, and we write them down here. This is where we actually process those messages coming in. Handlers are going to import the keeper. You can see it here in this function here, because the handler is sort of like trying to figure out what are the updates that I need to make to that keeper. You know, that keeper gave me that set and that get function, but this is where you really put the logic for like, should you be allowed to set that right now? Should you be allowed to get that right now? This is where you have like a lot of permissions, or really where the sort of like thinking part of your app goes. In Model View Controller, they talk about fat models and skinny controllers. The handler is a bit more like a controller, and the keeper is a bit like a model. And we kind of have the opposite perspective. We want to put all the logic inside of the handler instead of in the controller. So instead of fat models, thin controllers, we have fat handlers and thin keepers. So here we are dealing with this type scavenge on handling this create scavenge. Let's just look at this one. This is where you get that message. And you remember that message has basically all the same information that's necessary for scavenge. So we use that information there. We're missing those two final ones, which are what is the solution and who solved it, because we don't know at this point. First, we want to make sure, has somebody already made this scavenge? Does this exist already? If it does, you know, scavenge with that solution hash already exists, error, transaction failed. Now we do something called a module account. So you can see we talked earlier about SDK account addresses. This is like a basic user who's able to do things on a blockchain. Similar to on Ethereum, where a contract address is almost like a full-fledged individual. It can do things like a multi-sig wallet, you know what I mean? That's really a contract, but it's acting like a person that controls things. There's a similar concept here, which is a module account. So this is like a user account that is attached to an actual module. And you can generate that with a hash of the module name. That's how we're doing it here. So now this module is able to do things like hold coins. And that's exactly what's going to happen when you create a scavenge, because you're basically putting up a bounty and you're saying, okay, I'm going to give somebody $100 if they find this. You want that $100 to be held in escrow until somebody solves it. And so it's being held by the module account. And that's where you see here, coin keeper. This is the keeper associated with the bank. You know, earlier we got a hold of the keeper from them. One of those functions it has is send coins. So this is a bit like set balance of user according to these transfer logic. It just includes a couple more sort of instructions built into it. And that's saying move it from the scavenge creator, move it to the module account, and the amount is a scavenge.reward. So if there's no error, that's great, keep moving. Now you're going to set the scavenge in our keeper. So now that we've built this scavenge struct, now that we successfully locked up the coins for it, let's store it. And then we're going to emit an event. Here's a bunch of sort of information about exactly what just happened. If you're familiar with Ethereum, front-end apps usually hook into event listeners because they want to know what the state of the blockchain is without querying every single storage slot. So usually they'll just query for events to know what happened and keep the app sort of updated that way. We do a similar system here. So that's sort of at the end of the life cycle of a message. After it's handled and after the keeper gets updated, it emits this event, and that sort of tells everything that you need to know at the end. So the same sort of logic is happening inside of the message commit, slightly different, you know, because obviously it has a slightly different purpose. This one says, cool, here's a commit, make sure that it's not, doesn't exist again already. If it doesn't exist, cool, I'll let you set it, pretty simple. Also emit some events about that. Here's a big one where you actually reveal the solution. So this one has a bit more complication. It says, okay, you submitted this plain text solution and we know who you are, your message.scavenger. So why don't we combine those two things, make a hash. This should be the solution scavenger bytes hash, which, you know, was part of that commit. So now that we turn it into a hash, make it into a hex string, we're going to be able to get that commit based on this key. You know, hey, did somebody already make this commit or not? If nobody made that commit, then you can't do that solution. You know, that's not valid. The whole point of this system is that only somebody who made the commit is able to get that solution. Otherwise, front running is possible. So the next part is the solution hash. We do a similar thing to just the solution. So now that we are, now that we believe that somebody made this commit, we want to see if this solution is correct. So we do a similar hashing. We turn it into a string with hex. And now we find that scavenge using that scavenge hash. If that scavenge doesn't exist, meaning nobody submitted one with that solution, then that's an error and that scavenge doesn't exist. The next thing you want to do is see if there's a scavenger. Did somebody already submit this and get the money out? If this is not nil, like I said, when it starts, that value is nil. If it's now not nil, it means somebody solved it already. Throw an error, scavenge has already been solved. So now that we know it hasn't been solved and that it does exist, we're going to reward you. We're going to pull out you as the scavenger and the message solution. We're going to add it to that scavenge object. We're going to grab that module account, the one who's holding that money for you. We're going to send coins from that module account to you because you got the reward. Scavenge.reward is the amount you get. Without the error, we're going to keep proceeding. And if that was successful, we're going to update the scavenge and the keeper with that new sort of updated fields of you as the winner and the actual solution. So we all get to see what it is. We emit an event and everybody else knows that you won the prize. So that's what's going on in the module handler. I mentioned the module account. Here's events. So in order for these events to get emitted, we also needed to find them somewhere. Let's really quickly do that inside of the types/events file. Right here. Paste that in and you'll see these are just the things that I was tagging in that event structure at the bottom of each of those handlers. Basically descriptive text that says, what is this value, you know, so that when you're listening to those events, you can know, oh, that was the reward, blah, blah, blah. Pretty simple. Next is the querier. So we talked about how messages are updating state. You know, at the very beginning, we talked about CRUD, create, read, update, delete. Messages are all about create, update, and delete, but you still want to be able to read data from your application. And that's what the querier is for. Querier is a bit like the handler, who is sort of saying, yeah, you want to do something. How should I make it happen? I'm going to access the keeper in that process. Except for the querier is doing it without updating the state at all. All it's doing is saying, yeah, what do you want to hear about? I've got access to the keeper. I can grab it and I can tell you about it. So let's jump into our querier file. It is nested next to the keeper. And let's do the paste and compare thing again. So /keeper /querier, paste over and go to our Git. Check the Discord quickly. Are we doing okay? Thanks for coming, Silly Tuna. Okay. Querier, that's what we're looking at. So, looks really similar to the handler. You've got the switch function at the very beginning, and it's saying, okay, what do you want to know about? So we use something called a path. It's a bit like a URL. So if you're familiar with like file structures or URLs, you know, it'll be like mywebsite.com / big concept / small concept / extremely specific concept. You can use that with your queriers. You basically nest exactly how specific of a query you're making. We're using just sort of single path, which is why we only have the first one to check. And we have 3 different query types. We want to list all the scavenges. We want to get a specific scavenge. And we want to get a specific commit. So each of those queries have functions that are defined here and written down here. we have a little utility here, remove prefix from hash. This is, remember when we have those prefixes earlier inside the key, this helps you just read it more quickly. It's a common tool in this situation. So list scavenges, this is where you'd want to use that iterator. So we have that iterator defined on our key, and this is an iterator type. So this is kind of a helper system that comes directly from the Cosmos-SDK, because this is such a common data pattern that you're like going to be reading through a keeper really quickly. Put it inside of a for loop. If the iterator is still valid, iterate next. It removes that prefix, which means you actually get the hash, and then it adds that hash to a list. Marshals that hash into something readable, and if it's if there's no errors, it will return it. This is what a querier looks like. Here's a similar one where we're just asking for a single scavenge, and that's where you would have the solution hash, basically the ID of the scavenge. We can use our keeper to get scavenge, pulls it out. There's no error, keep proceeding. We marshal it. Again, it's actually marshaling these into bytes. And so if we got it, we can return it. And commit, same thing. Instead of looking for the solution, we're looking for the commit. Does the same query inside the keeper, and it returns it back to whoever's calling it. So they're pretty simple. You'll notice though that there's new types here. There's ones at the top, these types.query list scavenges. We haven't defined those yet. So let's put those inside of our types folder. We have another file already generated for us called querier. Pretty empty here right now, but we can overwrite it. And now we can say query list scavenge, query get scavenge. And this is where that path comes. We're just calling, that string list get commit. So the actual path is going to be the module name. So it's going to say scavenge/list. That's kind of like the URL for each of these queriers. We also have this special type, which is query result scavenges. And that's just an array of strings, because in Go, there's no such thing as array of strings. And if you want to be able to print an array of strings out as a string, you have to define it as a stringer. So we define a custom type there. That's just a very simple type. Like I said, it's just an array of strings, but it has the stringer function, which allows you to print it out. And it does a simple join with a new line in between each value. So let's go to our command line. So we've got this querier part of it, but we still don't have really a client that will utilize that querier. You could technically ping a Tendermint node. So from one of the validators, they have like a query endpoint. And if you correctly constructed that like RPC request, it would return basically an array of bytes. And then you would have to know the type and do that manually with JavaScript or some other client library. So we're going to build a client library right now that helps you do that. It's sort of comes out of the SDK, out of the box. It's a command line interface. We also have a REST server that we have available for you to build out of the box. And that allows you to sort of query an endpoint and say, hey, this is the query I want to make. What is the state of this thing? It's a lot more similar to like a traditional web app building experience or something like that. We're just doing the CLI because it's super minimal. We don't need the REST one in our situation. So the CLI consists of two components. One is TX and one is query. TX is for building transactions, submitting them to the blockchain. And query is for building queries. Say like I just mentioned, you could hit the Tendermint endpoint directly, or you could use this little library to sort of construct your query correctly and also parse the results correctly. That's basically what the TX is doing as well. You could hit the Tendermint endpoint directly, but you'd have to have sending to it like a correctly constructed object that's serialized in the right byte format. And you'd also have to, you get back, some crazy looking byte thing that you'd want to format correctly. So these are the utilities that help you do that. So let's take this and copy over our default client inside our CLI, the TX. We'll do our fancy compare, see exactly what we changed. So we made some different imports. They have the default get tx command, and then we added these three commands. So these are similar to each of our messages. This is basically, give me a way to generate those messages. And we're going to generate them with a command line. Here you can see them defined more correctly. We're using Cobra, which is a CLI tool that's popular in Go. It has the sort of format for constructing new commands. We're going to call this command create scavenge. It has a parameter reward, solution, and description. These are the three things that you need to know when you're creating a new scavenge. You know, how much you're going to pay for it, what is the actual answer to the question, and what is the question itself. You know, the description is where you can sort of describe the question. A little bit of information about it tells you, you know, it's only supposed to have exactly 3 arguments. If you're familiar with Cobra, this will all be really familiar to you. This basically takes in information from the command line, takes the first argument and converts it to a coin type, takes the solution, converts it into a hash. You know, we've been dealing with these hashes this whole time, makes it a hexadecimal version of it. And then it uses that new message create scavenge that we created inside of our message file at the very, very beginning. And that's where you throw in these parameters that are necessary. Here, it's where it takes the user's address. This is the person who's constructing this, and validates it. You know, just make sure, let's not submit an invalid transaction, otherwise the validators will throw it out. And now you can generate or broadcast messages. So this is a utility that comes from the SDK that will check what is the currently running blockchain and submit it there. This utility will also listen if you maybe want to submit it to a remote blockchain instead of one that you're running locally. By default, it'll just submit it to the local one. Here are similar ones. This is committing. So this feels probably a bit like going through our keeper, where we have each of them defined, or through our messages where we have each of them defined. Each one is very specific to its use, but not so different from each other. These are the arguments you would need when you commit a solution. Really, you just need the solution. You can hash the solution here, and then you can submit the solution as a commit. You know, so this is where you get the from address. You've got the solution hash because you hash the solution here. And then you've got the solution scavenger hash, which is the solution plus you, the scavenger, that gets hashed as well. So this is the thing, again, that prevents other people from front running you. Generate or broadcast it. And finally, you have the reveal solution. This is the big moment where you get to say, hey, I committed, I know the answer, give me my money. New message reveal solution. It doesn't need a lot because all the hashing takes place afterwards. Generate or broadcast, and there it's in. So let's also do similar sort of utilities to allow you to query state and use those queryers that we just built. Inside of your client CLI query, we will paste over the default generated by our scaffold tool. And let's compare and see what it actually did for us. Is that this one? Scaffold X, scaffold, this one. Yeah, here it is. So it looks very similar. It's also using Cobra. This command generates 3 new. This is the list scavenge. This is the git scavenge. This is the git commit. It's just creating terms for you to use in the command line. This is, we're going to use a command called list to get them. Here we're going to use a command called git, and then we're going to put that solution hash. Here we're going to have the committed solution, blah, blah, blah. This is all pretty basic. It's using the same logic that we have in the rest of the app. It's just making it accessible. Oh, my dog is squeaking. Okay, that is basically the app. Okay, we need one more thing that ties that app together, and then we're going to be able to use it in any application. That thing that ties it all together is the module file. So if we open up scavenge/module and we paste over what's in here, we can see exactly what was changed and know what it takes to make a module. We don't actually need to change much here. This is just spacing, that's not anything. This sort of references that our module type has to adhere to the message type or the struct that is add module basic, meaning all modules need to have that same format. Hi Hertz, yes, this is being recorded, no worries. Oops, how can I close this? Cool. Here's where it just returns the name. Again, I mentioned that we are recording the name somewhere else from the generation of the CLI. What else do we have? We don't really have much else. Here we go. So something that's unique about our module compared to others is that we're using that coin keeper. So we have 2 keepers inside this module. That's a little extra. And so while you're defining this module, you need to make sure that that's part of the definition. So generally you only have 1 keeper, but we have another one. So we added it here. When you're generating this new module, you're gonna have to make a reference to the fact that it has not only your keeper, but another person's keeper. And that's where you build it into this new struct that we have a reference to the coin keeper, otherwise called the bank keeper. Besides that, we don't really have any differences. This looks a little different, but you don't need to worry about it because we're not doing anything with end block. This is kind of cool to note though. So begin block and end block, these are functions that will get executed at the beginning of every block of transactions and at the end of every block of transactions. So say you had like 10 users do some action within a block. At the end of the block, you want to sort of make a summary of everything that happened in that block, or maybe like they all make bids on something, but you don't know who had the highest bid until the end of the block. At the end of the block, you could clear all of those or something like that. So it's a little bit like you could almost think of it like a cron job. It's a feature that I think is really exciting about the Cosmos SDK that sort of enables a more traditional app architecture than what's usually possible in smart contracts. So let's see that. And now your module is done. Of course, we're not just making a module, we're making an app as well. And so we want to modify our app to use our new module. So let's not forget, everything that we've been doing so far is inside the Scavenge folder, inside here. A little bit higher up, you can see the app. And this is where we pull in all of those traditional modules from the SDK. We've got the bank that I mentioned earlier. Auth is basically handling users in general. We've got staking and slashing. These are things that help with proof of stake, public proof of stake. But now we have a new module, which is called Scavenge, and we want our app to use this. We don't want it to be just basic. If you were to run this right now, this is essentially the Gaia app. This is the Cosmos Hub itself. It has all the sort of like basic features of a blockchain. I think this one's maybe missing governance, which is a big feature of the Cosmos Hub, but you could just import it here as well. So when we use that scaffold command that was level 1 means it's super simple. It means it doesn't include stuff like governance. But if you had the next level, level max or whatever it is, it would put the whole kitchen sink. It would have governance, all that sort of stuff, plus whatever sort of extra modules you put in. So here I've made some changes to the app file to use our new module. Let me overwrite it with those changes and we can see what those changes were. App. Okay, so the first thing you'll notice is that we changed the default command line interface home. So we've made these new command lines, right? And actually we forgot to, but we're supposed to rename them Scavenge CLI and Scavenge D for Scavenge daemon. By default, they're created as app CLI and app D. So let's go into our X Scavenge client. Let's see, no, it's actually we want them to be here inside of our big command. So this is where all of the command line interface abilities from all of the modules are combined. This is one of the reasons why you need that module file, because that sort of tells you what can this module do. And when you know what a module can do, you can do things like group all of the module's capabilities into one file of command line interface and make it accessible. So did I make changes to that already? What are we at? That's actually what we're doing next. So we're going to update those names. Before we update them, let's just reference the changes that we're about to make in that app file. Here we are. So we're going to change the name from app CLI to Scavenge CLI. We're going to change it from app daemon to Scavenge daemon. And we're going to add our new module. So the scaffold says, please add your modules here. We added Scavenge. We referenced it is following, the module interface. It has all the features of a full-fledged module. That's great. So where else do we need to notify our app that we exist? These are all just formatting changes, capital K to lowercase k. Don't need to worry about that. Here we go. So here's our keepers. This is all the keepers from all the other modules. Let's add our new scavenge keeper there as well. You'll also notice that the bank keeper is there. So don't forget about that because we're going to need to reference him later. Now we initialize a new app, and that's basically just formatting. I think it just made a new line, which is why it looks a little different. The other big change here. Okay, so now we've got all of the keys of our modules. And this is where we need to add our scavenger store key. So now our scavenger has a keeper, and that keeper has a key value store. So this is sort of a namespace for all of the storage that takes place for this module. That needs to go inside of there. And now we make, all of this is just formatting. None of those changes are real. Formatting, formatting, formatting. So this is where each of the keepers for each of those modules are initiated. Some of them have reference to other keepers, like the supply does. Some of them don't have any reference to any other keeper. Our scavenger, we know, has a reference to the bank keeper. This is where we reference it. So app was defined up here. This is the new app. And this new app, we know, has subspaces for all of these different modules. That's where the bank was added, for instance. So now we can reference the bank inside of that app object like this. We can create our new keeper. We know that our new keeper requires the coin keeper as the first parameter. And now we put our module inside of the module manager. Since we've initiated it with these proper sort of references, it joins the rest of the modules inside of this app. This is where Genesis files can determine which transactions are processed first. This is sort of like how important is the scavenger in a way. Don't really need to worry about this unless you're doing more complicated stuff, but maybe it's actually nice to talk about Genesis in general. So when you start an app, you've got all these modules that have different capabilities, but maybe they need to begin with some initial state. So that initial state can be added into the Genesis file. These are basically updates that you can make before the application even starts. And you're gonna run through all of those updates in some order. And this is where you can decide, which module needs to have its updates made first, because some of them are dependent on each other. We don't really need to worry about it because we're not dependent on anything. Actually, we're dependent on the bank. So we wouldn't want to be before the bank module. That's a good point. The rest of this is basically formatting, begin blocker and end blocker. So this is, again, that same sort of concept of a transaction or functions that can be run at the beginning of a block or end the block, but this is for the entire application, not just a specific module. Cool. So let's go back to our big command line interface and our big daemon to make the changes there to make sure that our new module is being accessed inside of them. So first let's go into app CLI. That's when we're told first, right? Yep. Overwrite that. Let's see the changes. I think they're pretty minimal. Most of the scaffold should do the work for us in that situation. CLI, where is it? Maybe it's still waiting. Oh, it's main.go. Yeah, this one. So this is, we're just changing the name basically from app CLI to scavenge CLI, giving a little information that says, yes, it's the scavenger client, not a big deal. I think basically everything else is the same. Some notes are removed, but that's it. We're gonna do the same for our daemon. I think again, those are kind of the only changes we make, are just letting it know that we're no longer calling it appd, we're calling it scavenged. We'll hop into the changes. Here's one main, app CLI main, where's the other one? There it is. So we import the app and we just reference that it's called scavenged now. Not really anything else. Cool. Now we can go ahead and actually update those file names though, like I said, we're gonna need to do. So it's actually these folders. So we're gonna rename this folder, instead of appd, we're gonna call it scavenged app CLI. We're gonna call Scavenge CLI, great. Let's do the same inside of our make file. That generated them by default with app CLI. So we're going to overwrite those now and let them know that it's called scavenged and scavenge CLI. So this make file is basically where it tells Go to build, squeaky dog, where it tells Go to build these new utilities, these command line interfaces that we generated, as well as the daemon, which actually sort of runs the application itself. With those changes, we should be ready to build and run our application. So the first thing you're going to want to do is run go mod tidy. Go mod tidy will build the go mod file and make sure that it has all the correct versions. It's basically building the package.json file if you're familiar with JavaScript. Once you've run go mod tidy, you should be able to run make install. This is a moment of truth. Drum roll. Actually, what happened to our, it's Giraldi. Looking okay. We got a chat. Great call. We forgot to replace SDK tutorials. So the reason this isn't breaking while I'm doing this right now is because the SDK tutorials is essentially up to date with all the changes we just made. So whenever it's importing one of those files, it's actually going to GitHub, grabbing the tutorials file and pulling it in. But since that file is the same as our local version, because we just made those changes, you're not going to have any errors. But that's a great point. We don't actually want it to come from there. We want it to come from our local versions of it. So we can do that search and replace. And that was Cosmos-SDK tutorials, right? And we're actually going to replace it, at least I am, with my username. So the SDK tutorials actually has this app nested one layer below, which is why I'm going to replace both Cosmos and SDK tutorials with my name. Let's replace all 16 occurrences across 12 files. Let's try it out. Move this down. Okay, let's try go mod tidy again so that it gets rid of all of those incorrect references to the Cosmos GitHub. Invalid version, oh no. Let me scavenge. Maybe if I remove my go sum, that's kind of like a package lock. Try it again. If we go back into go mod, what happens if we just remove that, and then we go into a file that references our good one and save it. Does it update go mod? Not quite. Let's try go mod tidy. That looks okay, but it's still not in there. What happens here? No, Dennis, why did you make us do it right? Okay, so let's try it manually. We can do go get, is that how it works? A great time for Go experts to pop up. What do we got going in the chat? Who's got some advice? Slash all those scavengers. That is not relevant to what we're doing right now. Let's go back in here. We don't need that either. I need you, Prince Giraldi. We want them to add our local scavenger hunt So I just added there. Okay, let's try reloading. This might be a VS Code freaking out thing. So save it again. Say, is that okay? Now if I go to my go mod, it's gonna have okay with me. Actually, it shouldn't have it because this is the thing itself. Okay. So let's try that again and see where the actual error was. I see, the error was in Genesis file. So that was, I just opened that and realized that it was importing from the scaffold. It had import ABCI or something like that, and it wasn't being used. So that was an unused variable error. That's why it didn't build before. It might be okay. Awesome. So why don't we run scavenge CLI help just to make sure it works. Nice, we've got it. Scavenge D help, it works. Awesome. Cool. So this error that you're talking about, Kendall, that makes me think that you might still be referencing the one on the server. So if it's like a Tendermint error in there, somewhere along the line, it's referencing the wrong version of Tendermint and it's trying to import it. So if it's pointing at the wrong version of the SDK, for example, that's referencing the wrong version of Tendermint and you get an error like that. I would try deleting GoSum and then look into your Go mod and compare it to SDK tutorials repo. Again, if you want to sort of just jump in with a working version of it, clone that repository and change directory into scaffold, and you should be able to run go mod tidy and install. No, that's not what we're here to do, but that's an emergency version of it. Fatal, no names found, cannot describe anything. Okay, so when you run go install version.name new app, that looks like you didn't update your make file. No, it's a new app there. Okay. Fatal, no names found. Can I describe? I've never seen that error. What's that error? That might not be a big deal, actually. That just means that there's no tags inside of the Git repository, which is true. So that looks correct, Sid bitch. It's ugly, but that's not an error, I think. See if you can run. Do you see anything when you run that, Sid? Cool, okay. So if we've got scavenge D and scavenge CLI, we can run our shit. We've got some more. It says command not found. Okay, might be if you just installed Go, I ran into this error earlier today, and I did not find Go bin inside of my profile at bashrc, then it will choose basically your root bin folder to install this command in. So it'll build it successfully, but it's putting it somewhere that's outside of your path. And so when I had that happen on my server, I realized that I just needed to add to my path my root bin. So I'll pull that up here. After make install and scaffold, there is no scavenge inside. I'm not sure what that means. Can you explain? So he's saying something about scavenge folder inside of the scaffold. So I think actually I even did the same thing here because we did git clone scaffold make install inside there. We were still in that directory when we started building our scavenge app. That probably something you shouldn't do. I think we did it and should work because you stay inside your scavenge directory when you're running all those commands. But typically you would have, your scaffold folder built somewhere and your scavenge application built somewhere else. So if you just re-clone scaffold or something like that, maybe you overwrote all of your scavenge work. I'm not sure what the question is exactly, Kinda-X. What are the sources of Scavenge? So Scavenge is the app that we just built. We made a new folder called Scavenge. We put all these files inside of it. If you want to just have a completed version of the Scavenge Kindex, you can clone that from GitHub/SDK tutorials GitHub/Cosmos/SDK tutorials. I put that link right above. I'll put it again. Kindex, you can always download the completed application from the GitHub and build from there. You're just going to want to make sure that you change directory into scaffold, or into Scavenge, which is a directory inside that repo. And then, yeah, so Florian's pointing out that if you followed me exactly, you did the same thing as I did. You actually built your Scavenge directory inside of that scaffold directory, which is a little dumb, but it shouldn't cause any real problems. Uh-oh. Okay, so the final steps are actually running our blockchain. I've added a bunch of these instructions one at a time. So we're going to add keys for me. We're going to add keys for somebody named you. We're going to initiate the blockchain by giving it a name called Scavenge and a node called mynode. We're going to generate these Genesis accounts. So these are like who has money at the very beginning of the blockchain. We can make me have some foo and some stake. Stake is used for the actual proof of stake aspect. It's just another type of coin. We're going to add some configuration to the CLI. So this creates a config file so that you don't have to use a flag every time. That includes stuff like what is a chain ID? How should the output look? Should there be an ender? Should you trust the node? You just do it once and you don't have to do it a bunch of times. Then you're going to run a gentx command, which is basically the first transaction that starts the blockchain. What do we got? Okay, we got an error. So it looks like you did not include types. Dennis, do you remember stage? I think that was within our keeper. Let me look at your error again. Commit prefix, that was part of the keeper, yeah. So in the keeper part, you scroll down and you've got prefixes. I'm just gonna, if you're not following. So from that stage, we made this new file called types, Dennis. That types file went inside of the types folder. And that is where we, no, sorry, the prefixes goes inside of keys. So key.go is a file inside of your types folder, types/key, and that's where you want to put your commit prefix. Because you're getting an error, it looks like, that says it can't find the commit prefix when it's being referenced inside of scavenge.types. So either it's not added to that Go file, or you don't have the alias file. That's another thing it could be. So these are all being called from Keeper and Querier. Keeper and Querier need to have the alias file reference everything inside the types folder. Otherwise, it doesn't have access to it. This is what I was talking about. If you're inside the types folder, you can see everything else that's inside of all the other types folder. But if you're a level up, the way Keeper Handler is, you're going to need access to something called alias. And so that's where we import those different things. Although I don't see prefix as part of that, so I imagine that's not where it's coming from. We could also jump directly into your Keeper file and look at line 49. Let's try that. It was line 93. So this is types commit prefix, and it imports the types up here. So if inside your Keeper, you should be able to see, Dennis, importing the specific types. And that's this, it's basically importing everything in this folder. So that prefix that it's yelling at you about should be inside your key.go file. We got a fresh clone and an error. SDK tutorials scavenge. Bitcoin D. That's a weird error. So it looks like you wrote the word router key WW, Dennis, inside your undefined. So I think that's probably just meant to be router key without the WW. Kind-X, that is a weird error. Let me, no problem. Let me try doing the same thing as you. So if I were to make a new folder and get out of scaffold entirely, do git clone, git at github.com, Cosmos, SDK tutorials, cd SDK tutorials, cd scavenge, go mod tidy, install. Fingers crossed. So looks like I can't reproduce your error Kind-X. Are you? Did you clone the repo exactly like I did and move into the correct folder exactly like I did? I'm not sure what would be going on there otherwise. Alessio, if you're still here, you know what might be happening. It looks like he's importing the wrong version of Bitcoin D. I don't know why we're using Bitcoin D even. Kind-X, doing fresh install and getting error on the version of, what is it on again? BTC Suite. Maybe Alessio can reach out directly to Kind-X. That seems like maybe some Go mod, very specific, like to your location, maybe. Okay, otherwise, I'm gonna jump back into the tutorial. So I'm kind of going quickly over this run part. where I tell you each of these commands, because I have another section down here where I put all of them into a single command, which makes things a little bit easier. And it also has this command at the beginning that says remove from scavenge.cli. So this is a folder that's created in your home directory that stores configuration files as well as the actual data of your blockchain. And if you're developing like this, often you need to destroy those folders because they have like conflicting data from what you're trying to do. So whenever I'm creating this sort of like init.sh files, this file is actually inside of the GitHub repo. So if you want to just run it with ./init, you can do that. Otherwise, you can make a file or you can copy all these commands and run them. Other big difference here is that I'm using the keyring backend test. So if you were running any of these commands above, you'll notice that there's different password management systems for your different environments. There's a lot of settings about it if you're on a Mac versus a Windows, Ubuntu. If you don't want to deal with sort of like typing in the password every time you run a command, something you can do is use the backend test. So this basically is a super unsecure key management system. But if you're just testing your application, that doesn't really matter. And it means that you don't need to add a password to all of these other commands. So I did that for the sake of brevity. You'll notice also down here, scavenge-d. So because it's part of a config on scavenge CLI, it just uses that backend every time you use scavenge CLI. But scavenge-d has a different config that actually doesn't exist. So when you want to reference that same backend, you actually need to be explicit on a command like this one. You tell it, hey, I'm using that test key backend. So I'm going to copy all of these and run them really quickly in my terminal here. It's going to nuke my config file, nuke my previous data, initiate a new blockchain, tell me to use just the test keyring backend. It's going to add me as a key user. This is like create a new account called me, create a new account called you. We're going to add me and you to the genesis. You know, this is the very beginning of the blockchain before it started. You might want to add some information to it, which is who has money. That's us. We're going to set up the configuration of the CLI. We're going to make sure the chain ID is always set as scavenge. Output is going to be JSON to make it pretty. Indent true, make it pretty. We're going to configure it to trust the node that we're talking to. And then we're going to generate the first transaction. And that's from me, username me, because that's the one who has the stake. They're actually going to be running a validator. It's going to be a single validator blockchain. They're going to be using that keyring test, which is super unsecure. Scavenge-d collect those generated texts, those genesis transactions, which only is one of them. We can run all of this stuff and you'll see the output. This is information about my new public key, private key. Here's my mnemonic phrase here. So this is super insecure, obviously, that I'm just showing you all this stuff just for testing. Here's where it saves the config, and this is the genesis transaction information. So now that I have all of that, I can actually run a blockchain. And I can do that with the daemon. So scavenge-d start. And now this blockchain will begin. So on the dot of 2 hours, the blockchain starts running. If you'd like to stick around, I think that we can actually get ourselves interacting with our own blockchains and then interacting with the remote one that I told you about at the beginning and start the real contest that if you win the most, you get some swag. Let me check here. Yeah, that's what I did too. Except I also did go mod. Maybe he doesn't need to do go mod tidy. Yeah, so if you can give some more information, Kindex, then we can maybe get you sorted out. Otherwise, you know, you'll see this command here, scavenge-d. We're running a blockchain right now. This is our application. Now we can start playing with it. So we've built this capability to make these types of transactions. Let's try them out. You might just ask what are those commands by using our scavenge CLI. So scavenge is our new module. It's under transactions. These are sort of messages that update state. So if you run help, you'll see this. It tells you what you can do. You've got our commands here, create scavenge, commit solution, and reveal solution. If you were to run help on create scavenge, it'll tell you the format that we defined earlier. You need to tell it the reward, solution, and the description, and if there's any flags. So why don't we go and create one? Really hilarious one. What's brown and sticky? The answer is a stick. We're going to create the scavenge. We're going to give away 69 foo to whoever can solve it. I'm just going to copy this command And I'm going to jump over here, make a new window, because we have to keep that old window running with our actual blockchain. So, get out of the way. If I run that, it's going to show me a preview of the transaction. It says, you know, this is the message type, the create scavenge message that we created earlier. Here's the creator. That's my address, my account address. There's the description, what's brown and sticky. Here's the solution hash, and here's the reward. The denomination's in foo, and the amount is 69. Let's see, we got a chat. Hi, Adriana. Confirm transaction, yes. Because I'm using the test keyring, it doesn't ask me for a password. So that's my submitted transaction. I can copy that, and I can run scavenge CLI. I'm going to query this transaction. This is a pretty common command. You just take the hash, and you can say, did that succeed? You know, this tells you everything about that transaction that just went through. Looks like it was successful. Here's the events which were triggered upon successful processing. You know, this is the events in the handler that we talked about. You can see there was also a transfer, which was from me, the amount of 69. This is me sending that money to the module account, that escrow account. Sorry, this is the recipient. That's actually the address of the module. Here you can see the original message, the gas that I paid. I didn't pay any gas. It requires this much gas, but at a fee of 0, you know, 0 times that is 0. Here's my signature. This is what I used to verify I really made this transaction, and the timestamp. So if we wanted to say solve that, you know, let's use our solve transaction, commit solution transaction. We can also query, you know, what does it actually look like by running the help command on it. But here's what, if you account, the account I made called you, wanted to solve it. First, they would commit the solution, which is a stick, because we know what's brown and sticky, a stick. So you can make that. And now it says, are you sure you want to sign this? Yes, I do. Here's the transaction hash. Let's query it again. And here we go, a successful commit. We can see the information here, the scavenger who's trying to make the claim. That's the solution hash. So that's the word a stick that's been hashed. And here is a stick plus the scavenger's name that's also been hashed. So it doesn't reveal the answer anywhere, it just reveals that I know the answer. And now we can actually reveal it. So, this also lets you query specific solution hashes if you want to see like, oh yeah, this one exists, somebody made a commit to it. But let's jump ahead to actually revealing that solution. Here we go. So now it's a very similar command to the last one, except for this time you're actually sending the real answer. You can preview it. Yeah, this has all the real deal stuff. Say yes, sent. Copy that PX hash, print it out. Looks like it was successful. The solution was a stick. We can look at these events. You can see there's a transfer event from the module to me. That's 69 foo that the person, sorry, to you just received. Why don't we check use account with a common command that would be scavenge CLI q account. Here I use this sub command, which is pretty clever or useful here. So if you put a dollar bill in parentheses, then you can use a second command in the same first command. And this is where you want to show the actual account address. So let me just do that really quickly, and I'll show you that this person has 70 foo now because it began with 1 and they got 69. But if you were to run just that second command, scavenge CLI keys, this is also something you just inherited from the SDK. Sorry, we're doing keys. Show you, shows their whole sort of info, but if you were to add the flag A, it just shows the account address. That's often used as one of the parameters, so you're using that sort of sub-command pretty often. Awesome. You could get the whole list of scavenges. What does that look like? It's a little ugly because it just shows the hashes, which are essentially the IDs. And that's kind of where we can stop our self blockchains. But what's really exciting now is that you can actually interact with mine. So the first thing you want to do that, let me just first check the chat. How are you guys doing? Cool, looks like Alessio is helping you out, Condex. Hopefully that'll get to the bottom of it. I see Florian. So if you are still with me and you want to, you can commit, you can do scavenge CLI config, and you can change the node that you're talking to. So you're no longer talking to this blockchain over here, basically shut that one down. You can tell it to talk to one that's located at this IP address. I will put this whole command into the, I'm not going to put it in there yet. Actually, maybe I'll do it for myself, but then hopefully I can just clear this buffer so nobody's looking at it. Because with that, let's see, now I need to actually get to the server to give some coins to people. So if you want to run scavenge CLI Q, actually just keys, show, and then whatever name you're using, if you're using me, show me, and then take that address and paste it in there. You can even do one better. Why don't we add that A flag that we were just talking about. So if you paste your address in the Discord chat, I will send you some tokens on the live one. Here we go. So I'm coming in. What's going on with my SSH? All right, we've got 4 people, 5 people who are still with me. That's amazing. Why can't I? Yeah. Should not be taking the time. Looking at all my shit, you guys. Why don't I stop share for a second? Looks like anything's wrong with the server. Also try turning it off and turning it back on. That works sometimes. Why don't we do that? Jump back over to the chat. Now, cool. That's 3, 4, 5, 6, 7 addresses. Anybody else competing? We might get Kindex here in a minute. Oh, does anybody need a break? Stretch break, bathroom break. This is a good time to do it while I'm just configuring this. Could also be. So I was opening up ports on it, which I'm not super familiar with. Let's see, open ports Ubuntu, or copy and paste. Something like UFW. Okay, if anybody's listening, if I use sudo UFW allow and then put a specific port on there, does it close all my other ports? That shouldn't happen, right? So maybe that's why it's not letting me access anymore. That would suck. I didn't whitelist any addresses. I mean, by default is UFW enabled. If I enable it, does it then prevent everything else? So I think I did something like 2, 5, 5, 6, 7, or 2, 6, 6, 5, 7. I think I did something like that. And then I left my connection. No, but I connected a bunch more times after I ran that command, so that can't be it. Operation timed out. Why are you timed out? I try to log in with some weird port. No. I try to log in with some weird name. Oh my God, either. What if I try to jump in the custom console on DigitalOcean? What if I try to send myself reset root password? Instead of using my SSH keys. So root password has been reset and emailed to me. Not sharing my screen with you all anymore, so don't look. Can't look. Okay, so I've got the password. Launching the console. Root password. I'm in. Okay, so tmux attached. Do I still have my process running? Okay, so tmux. We want scavenge D. Let's see. Scavenge D not found. SDK tutorial, scavenge. Should be make installed already. Scavenge D not found. One second, I'm just checking. install. Cheers, Ian. Okay, so I'm going to shut the recording and send everybody a follow-up email with, since I've got all of your addresses now, I can send you money. This actually maybe works better because I can send you money at the same time, so there's no race condition. And then I will send you the IP address. So you can just do this in your own time. Maybe I'll even start tomorrow morning since there's some people on that time zones. I'll just, as soon as it's ready, really, actually. And whoever gets the most points at the end of, I don't know, a week, let's say, or when all of the questions are done, I will follow up with you on Discord because that's where I have your addresses and get you some swag. So thank you for coming to the first run of the Code with Us. Clocking in just over 2 hours, a formidable tutorial. We got through it. We've all got running blockchains, I believe, at least a handful of us do. And keep an eye out for the instructions on the real contest where you get to win some swag.